basic check here. If I said, what's the absolute value of -5, what do you tell me? 5. If I say, what's the absolute value of 7, what do you tell me?
7.
Okay. Does anybody remember the actual definition of absolute value?
I forgot.
Has to do with the number line.
Same number with 0.
Yes, there we go. Absolute value is nothing more than the distance from 0. Because if I put a mark out here at 3, how many units am I from 0? I'm 3 units from 0. But if I put a mark out here at -3, how far am I from 0? 3 units. So absolute value is nothing more than measuring the distance you are from 0. We don't have positive, negative. If you live south of town, you don't tell somebody to get to your house by saying, I'm a -3 miles. Your distance is positive number.
There's a negative sign outside absolute value, so that makes another negative.
Okay, good question. Yes, if you had a negative absolute value of 6, it will still be -6. Since that is outside, it stays negative. Yes.
You call that an opposite, or?
You can call it an opposite. You could call it an opposite. Yeah. You could. Okay, well, what we want to do, I know you guys know how to work problems with absolute value. I want to solve equations that have absolute values.
Yay!
Yay! This is not hard. Be cool. It's okay. You won't die from this. Okay, common sense. If I say the absolute value of x equals 4, what are the possible answers x could be?
4 and -4.
It could be -4 or +4. Yeah. So the key thing to remember is when you work in absolute value problems, there are almost always 2 answers because there can be a positive or a negative choice. So if you see a problem with an absolute value in it, there's going to be 2 situations happen. What we want to do then, I'll make it a little trickier, a little harder to reason out. If I gave you the absolute value of k plus 6 equals 9. Okay, we instantly come up with 3. We get that answer right away. But what's the other number that you could put in there that would make that come out equal to 9? Because -3 plus 6 would give you 3. Wouldn't give you 9. There we go, -15. So what did you have to think about to come up with -15? What plus 6 would give you -9? So what did I have to add if I did that plus 6? So what you just did when you worked this problem is you said, okay, what plus 6 equals +9? And then you did what plus 6 equals -9. So when you solve absolute value equations, you always set it once equal to the positive number, and then you write it again equal to the negative number, and you solve it. That's how you get your 2 answers. That's not major, tremendous, horrible thing. Well, let me throw you one more wrinkle.
I always thought it was easy and then there's something else in there.
What if I put some other terms in the problem? What if I give you something like that? Do I set it equal to 0 and -0? Suggestion?
Count the bars as absolute value, like parentheses, and you finish distributive property?
No, you can't. Because you would be distributing negative in there. So, yeah, those bars on the absolute value, that is a force field. You cannot penetrate the force field or you will be blasted into oblivion. You can never cross into it. Okay. What you need to do, yes, is you've got to get your absolute value isolated. Get your absolute value all by itself. So what would I have to move to get the absolute? Okay, this 2 is times the absolute value. You would have to subtract the 12 first, move it to the other side. Now, how do you get rid of something that's multiplied? You would divide it out of there, so you'll divide by -2 so it cancels. And divide this side by -2. Now I will have x plus 2 equals 6. Now the absolute value is by itself. Then you can solve it like this one we did right here. anytime you do absolute value, you go, I have to have two equations. So, what would my two equations be here? Not answers, equations. I would have x plus 2 equals 6, and I would have x plus 2 equals negative 6.
So pretty much you have a positive and a negative no matter what.
Am I out of space? Must be out of space, okay.
Right?
The final answer wouldn't have to end up negative. I'll give you an example. So yes, you're going to get 4, and you're going to get negative 8, and you're going to have those two answers. Okay. So the key thing is when solving, hint, this is on your journal, I asked you for 2 steps to solve absolute value problems.
Yeah. Absolute value.
You have to isolate the absolute value, get it all by itself. Isolate, that's not good. Probably, I think, I don't know the exact number, but isolate the absolute value, and then you write and solve 2 equations. Not 1, 2. You get it by itself, write 2 equations out, and solve it. And when you write the 2 equations, you always do one equal to the positive version of the number, the second one equal to the negative version of the number. Does that blow in your mind?
Yeah, completely.
Completely.
I don't get the line.
You don't get the what?
No, I get it.
Are you talking to me or him?
I'm talking about this.
Okay.
He just added literally.
You said I don't get the something, and so I didn't know if you were talking
He
to me.
doesn't get the last chapter, so why would he get this chapter? Is what he said. Yeah. Not the last chapter, the last assignment.
Because that was testing points. That's a different thing.
That was hard.
It was. I agree.
It was professionally easy.
And I know from a fact that when you practice with it, it gets better. Because then by the next time I do it, it's like, oh, that was no big deal. It happens. Okay. Now we're going to do the exact same thing, absolute values, same 2 steps, except I'm going to change one tiny thing.
Tiny thing, that could be a negative multiplying by.
What happens if I put less than and greater than in them?
I have no idea.
Well, let's go back to remember, absolute value is the distance from 0. So if I said, shade for me the answers to this, where would all the points be that have a distance less than 3?
0.
So there's 3 and negative 3. Where would the distances be that are less than 0?
Negative 1, negative 2, negative 3, negative 4.
Okay, so he said negative 1, negative 2, negative 3, so you're doing all of these.
Yeah, yep.
And it's supposed to be open. And then any positive answers?
Yeah, 1, 2, 3.
Yeah. And that would be open. Okay? But now, come over here and do a greater than. You don't need a coordinate system. Erase.
Okay, hold on.
2 and negative 2. Okay, so now, what if that's absolute value, that's saying my distance has to be greater than or equal to 2. So then where am I shading? Closed to?
Are both those circles not doing the 3?
Yes, they are. I kind of messed that one up. They would both be open, yes, because there was no equal sign. But what is over here, and where would they be if it's greater than 2?
Obviously outside of the 2.
Because you would want distances greater than 2, so your distances would be out here and out here. Okay, we just did and or problems.
Really?
Which one of those had answers that looked like this, that were trapped in the middle, and which one typically had answers that were out on the edges?
Or an and.
So which was an and which was an or? And was where they were intersecting. So we were typically getting answers that were where they crossed each other. Ors were anything shaded, and oftentimes they're going in 2 different directions.
So it's the second.
So what you're going to remember when it's a less than sign, you're going to think less than.
Oh, I remember.
If it's less than, it's and.
Pretty sure you don't.
Yeah, I do.
And then, since this is greater than, we're going to think great or. Okay, so if it's a less than, it's an and problem. If it's a greater than, it's an or problem.
Great or.
So now, let me actually show you one to work.
Oh, it's number 11.
Yeah, I'm sure that's a question on the journal too.
The pointless problem is you can determine whether to use and or.
So I remember the saying about
Or is when.
Yeah, remember the saying, that's the saying, yes.
We got the same for 11.
Yeah, that's the saying, yes, less than and great or. I don't know which one I'm asking
That's
for.
major.
Oh.
Okay. Subtract 20.
Okay, so now, same steps. Isolate the absolute value, write two equations, but then you'll have to graph it at the end.
Can I get that paper that I gave you yesterday?
The homecoming one?
Imagine if you don't get all the answers. Hey, get out of here. I just did. No, get out. You're leaving.
She's got power. She's grading your papers. I wouldn't mouth off to her.
All great papers.
Or she will be grading yours. All right, so same two steps. You isolate, write two equations. Actually, in this case, it'll write two inequalities. And technically here, then just to remind you, you're going to have to graph the answer, because you can't tell on ands and ors, you can't find the answer until you graph it. So, how do we isolate it? Subtract 20. Okay, so if I subtract the 20, which would give me greater than negative 8, then divide by 4. And so I would get absolute value of 6x plus 2 is greater than negative 2. Now, what's it say to do once you isolate it? Write two inequalities.
Right? And it's all two equations.
And big hint, you can't decide if it's and or until you get it isolated. You have to get it isolated, then that sign determines whether it's and or. That one determines and or, not the starting one, because I'll show you one in a little bit when it switches. So now when I write the two equations, it's going to be, you write it down once as is, just as you see it. But then the second time, what do we have to do when we write them? We have to switch the negative to a positive, because back here on the equal sign one, can't see it. On the equal one, we wrote it once equal to 6, once equal to negative 6. So here we do it once greater than negative 2, once less than 2. But now, what are you asking me? She wants to know if we switch the greater than less than. If we switch the negative, yeah, you switch the sign. So you should always have one greater than, one less than. You have one of each when you're working it, yes. All right, so now, is it an and or an or?
It's honestly.
Looking right here, that is a
Or.
that is a great or. So we are an or. You must write the word in there. Come test time, it'll take off a point if you don't write the word in there. Now you need to solve and graph them, yeah, just like we did before. So if I solve that, that's going to be 6x is greater than negative 4. And if I divide by 6, x is, that'll reduce down to 2/3. This sign, didn't look black. This sign is your and or. That's great or. Now, what happens when I solve the other side? 6x is less than 0. You divide by 6. What is 0 divided by 6? 0. That's okay. You can have 0. There's no law that says you can't have 0. Are you done? You have to graph it. That's the kicker. I guess I am done. Right. So graphing it, I would have negative 2/3 and 0. Okay, which way from negative 2/3?
To the right.
Negative 2/3, right. And then open left. It's an or. So what do we want for answers on an or? Anything shaded, or is it where they intersect? Which one?
Anything shaded.
On an or, it's anything shaded. So therefore, what have we shaded?
Everything.
We've shaded everything.
All real.
So our answer here would be all reals again.
It's Mario, 16.
Thank you. Okay.
20.
Let me say what I wanted to say, and then I'll shut it off.
Okay,
Here. On this problem, you could have known it was going to be all reals, like right here.
Oh, are you disciplining?
Because right there, you could have told it's an absolute value, and it's got to be greater than it. If you end up with a negative number, warning bells should go off.
Warning bell.
Once it's isolated, you had an absolute value needs to come out greater than negative 2. Doesn't any absolute value come out positive?
Oh.
So wouldn't any number you put in there be greater than a negative 2?
Yeah.
Yeah. So if you end up with something being greater than a negative number, you instantly know your answer's all reals. What if you end up with something being less than a negative number?
You gotta work it out.
Can an absolute value turn out less than a negative number?
No.
It's no solution then. And we also should talk about if it's equal to a negative number, that's also, I wrote that wrong. If it's equal to a negative number, it's also no solution. So so if you when it's isolated, if you have a negative number, you can stop and look at it and go, oh, it's going to be either all reals or no solution. Okay, you all have to work the problem for me.
Hey, you're on 17.
Sorry.